Hi. After 3 phases of hard work, we gladly present you the final version of our project, iSuicide. Our project features 2 vectors of LEDs for each player, 2 detachable tapping stations, and a detachable battery pack.
So this is our project, and this building is supposed to simulate a haunted house where people just randomly jump out of the building. And as you can see, we have windows, and we have red LEDs and green LEDs. The red LEDs indicate the targets, and the green LEDs indicate your position. And the objective of the game is that you have to save the targets from jumping out of the building. And how this happens is that you have to tap on this tapping pad, and the frequency with which you tap corresponds to a specific floor. And you have to hold that the tapping frequency for 5 seconds to the floor that has the red LED, the target. And once you hold it for 5 seconds, then you save the target and the red LED will be switched off. And this is simulated in the other side of the building as well, so that both me and my partner here, we can tap, and we share the same targets, and whoever gets to them first that'll be indicated by a target saved sound clip.
To start the project, connect the tapping stations, connect the battery pack, then connect the battery pack. This way.
To the cursed building. Choose your difficulty.
Now to choose the difficulty, we tap to the chosen floor. This indicates hard, medium, and easy. I'll choose hard.
Hard. People seem to be jumping off of this cursed building. We have to save them. Let's start tapping.
Now to gain a point, we have to stay at these LEDs, at this level.
Target saved. Target saved. Target saved.
We'll demonstrate a full gameplay on easy mode.
Let's just see.
Welcome to the cursed building. Choose your difficulty. Easy. People seem to be jumping off of this cursed building. We have to save them. Let's start tapping. Target saved. Target saved. Target saved. Game over. Ta-da-da! Player 1 wins.
Now moving on to explaining the code. The first pattern that we have used was the observer pattern. We have an observer interface and a subject interface. Our observer in this case was the player, and our subject was the game board. So, in our subject, the game board, we get input from, we have the most useful function in this program, the get input. It distinguishes sources, then it notifies observers. To distinguish sources, we have a string, we call it try. This try string keeps getting reading from the Arduino itself and pushing it into an array, which is try. The first thing that it does is that it checks that the input that it's getting from the Arduino is not CAN. This CAN will be used later in the communication protocol. Otherwise, if the input is not CAN, the input will be pushed into the try string, the array of strings. Now, when this string is read, the input of that string is split for every player. The first thing inputted by the Arduino is going to be the ID of that player. So we push that here, then into an index value. Then the index value of the frequency array is that index in the frequency array will have a value inserted into it, which is the frequency value. Here we're casting the thing from char into string, into integer. We negate the integer of the integer value of 0 in order to scale it down, because it will give a high value. The frequency array is an array of frequencies of every player that is available in the game. Later on, when we notify observers, each observer will be notified by the change of the value of a certain index in that array, as you can see here. Observer I will only get the frequency I, so player 1 will only get the first frequency. Moving on to our observer, the player, it has an update function. This function is called every time an observer is notified. So here we check if the round is still continuing.
So this is our check round function. Now, before explaining it, we have two variables called master counter and goals. Master counter indicates the counter for the round, and then goals indicate the number of available goals for that round. So to check if the round is over, we check either if the round has finished time-wise, when master counter equals to 0, or when the number of available goals are done, so we have to move on to another round. And then whenever that happens, we have to set the goals back to 0, so that we can increment them when we set up the goal environment. After that, we just play a sound. Okay, so firstly in the check round, we have to check the possibility if we haven't saved any targets, and there are still targets remaining. So we check if the timer has run out and there are still available goals. Goals is greater than 0. Then we set goals back to 0 and we play a sound file that says I am falling, indicating that the target has not been saved. Otherwise, we check if the master counter equals to 0. That means that the timer has run out, or the number of available goals are done. That means that the round has finished. Then we set round over equals to true, and then we say if the round over equals to true, then we just we return false for the check round. That means that the round is over. Otherwise, we return true when we say that the round is continuing. It is not over. So going back to the update function, we check the check round function. If it is true, that means that the round is still ongoing. We just update with the player's current location, each individual player, and then the expected, so where the target is. And after that, we decrement the counter, the master counter. That means that one round has been over, and we enter the check win function.
We check if any changes in the frequency have appeared. If no changes in the frequency have appeared, and if the frequency that is being tapped at, if this criteria has been met, we proceed further. If the counter is not 0, we give the user a flag that he is locking down on a goal. So we keep incrementing until we reach 0.
This counter is a variable that whenever you reach a target, it starts counting. And basically, when you reach the red LED, you have to stay there for about 5 counts. And it keeps decrementing up until it reaches 0. If it reaches 0, that means that you have successfully saved the target. So if the counter equals 0, that means that we have successfully locked down the target for 5 seconds and have saved the target. And this is indicated by a sound, which means that target has been saved. After this happens, we increment score, which is a variable that shows the player's individual score. And then from the available goals, we decrement. So there's a specific number of available goals that both players share and must try to complete. So this number is decremented.
Then from the binary array, this value is the value that we tapped at is actually removed. And to fix that at the goal value, the hexadecimal value of the goal of all of the set goals up to 3 goals is changed accordingly. After changing that accordingly, the new LED the new LED setup is sent back to the Arduino itself. We'll get to that when we cover the command pattern.
And then we indicate that the target has been saved, and then we print the player's score, the player's name, and his or her score accordingly. And then we print out how many goals are available, just for observational purposes. Otherwise, if that criteria hasn't been satisfied, then we just reset the counter to counter initial. That means that you have moved to another target that's not the indicated target. Otherwise, if the check round function returned false, which means that the round isn't continuing and the round is over, then we will print out round is over. And we will increment the total counter, which will show you the number of the round that you're in. And now here we set up new goals. We set up a random amount of new goals, and we reset the master counter, which shows you the timing for the new round. And we'll get back to this env.getNewGoals later when we explain the strategy pattern. Now this is just the constructor of the player. You give it an environment and then you give it a name. And you just set the master counter, and you set the counter to the desired values. So the master counter will indicate the round, and the counter will indicate the number of rounds while you're locking down a target.
Now moving on to the strategy pattern. The strategy pattern here indicates the difficulty of the game. So difficulty. We have a difficulty of easy, medium, and hard. Easy sets those those values for the LED. Those are hex values, 5-bit values actually. So what those values actually share, that they only have 1 bit on, 1 bit that is high, and one of those values is chosen randomly.
And the same thing can apply to the medium and hard difficulty.
Now to control the red LEDs that are connected to the Arduino, we utilize the command pattern and the template method pattern. Template method pattern, because we have a function, we have its skeleton. It will be repetitive for every other command. So what this function does, it sets up a string, plays a sound, then waits for an acknowledgement from the Arduino to print a line to it. To explain the template method pattern, we have LED handle and diff on. Diff on concludes everything about this pattern. First, we have set output. Set output is basically a string. How do we set up the string? Using the set output in the daughter class here, diff on. It returns on to indicate that this command is trying to turn on something, then an integer. This value is indicated in the constructor of this class. Now the second function to be implemented by the daughter class is the play sound function. To play a sound, we open a clip, find it, we create a new clip, then we find it on the system, open it, then start it, which is a string, but we'll get to that later. Now after executing the inherited functions, LED handle, the command LED handle, waits for an ACK from the Arduino acknowledgement, then prints a line to the Arduino, which contains the command of turning on or off the LED. Of the game, the environment is basically the background music and the overall setting goal experience. The environment is actually the invoker of the command pattern. It has the exec function that will be used to set up the LEDs. It takes a command as an argument and does everything else. Another thing the environment class is responsible of doing is setting new goals. Depending on the difficulty, which is the strategy pattern, it will set up new goals. Then it will execute them. And the new goal will be returned and saved later as shown before in the player. One last thing this class is responsible of is the background music, BGM. The background music will start in the constructor. Whenever we have an environment that uses the non-default constructor, the background music will start. The default constructor will be used later on in the main, in the driver class. We have a background music class. The background music class is simple. It has a run method. It's not a thread though, but it has a run method, which runs a thread within it. This thread is a clip. Here, when we open our clip from our system, we will start running that clip continuously. Now for the driver class, where everything gets wrapped up. In the main method, the first thing we do is to open a new port using serial port handle. We open a new environment, an environment that has no difficulty, and we set up the port for the LED handle using this static function. We'll ask the user using a voice note to set the difficulty. To show which floors indicate the difficulty, we set the difficulty to 28, which turns on the highest 3 LEDs in the Arduino, in the building setup. Unless the Arduino is reporting the acknowledgement token, we read the value from it. If the value is sent from player 1, who is the only one who is able to change the difficulty, we take the value. When he chooses a value, the highest value he chooses, it will be taken. As soon as the player 1 releases his tapping, stops tapping, the difficulty will be set, and the difficulty will be set accordingly to either easy, medium, or hard. Noted that the environment will be set to an easy difficulty if the user somehow taps in an unknown manner. When the environment is ready, we are able now to initialize the observer and the subject. The subject is the game, and the observers are the players. The observers are registered, then a sound file indicates that the game is starting. Main loop of the program, it will keep running for 3 rounds, +1, because there is an incrementation that happens in the end, and this +1 is there to account that incrementation. If the game is not over, if the rounds are not over, we still get input from the game. Get input was covered in the player before. If the round is not over, we keep getting input. Get input exists. Was already covered in the game board class. The Arduino code. We separated our code into 4 different tabs to make it easier to read. The first thing to do is to define if this is debugging mode or not. If it is 0, it's not debugging mode. Debugging mode is used for debugging for using the serial monitor. Another thing we have to take into account is to check which player we're taking. For example, if we're taking player 1, we have to comment out player 2, and vice versa. And those setups are set for player 1, and those stuff are set up for player 2. Those stuff differ depending on the soldering. Now, we find the sum of that array, which is an array of 0s and 1s. We divide the value by this scaling factor to make the output scales up to maximum frequency. We return that value. The class that we utilize is the hexset class. This hexset class takes a hexadecimal number, it divides it into its integer, into its bits, then takes some corresponding pins out there and set those pins to those hexadecimal to those binary bits that were divided in the previous step. Moving on to the loop. Before the loop, we get an object of type hexset. 2 objects of type hexset actually. First one is for the second one is for the red LEDs, and this one is for the green LEDs. Those green LEDs are connected to a decoder, so they directly use hexadecimal values to set only one LED at a time, the green LEDs. However, here they're set using binary, and multiple LEDs could be lit at once. For example, 31 will light them all on, and 0 will light them all off, to turn them all off. Later on, we have an object of type frequency sampler with a delay of 10 microseconds. The maximum frequency is 55. It's greater than 4. Yes, we'll get to that later, and a threshold of 8. Those values were set by trial and error. Now we have strings to read from serial port from the Java code. A reader, on and off, num, and string. Now in the loop, the first thing that the loop does is to report the current frequency to the Java code, while serial is not available, and while the player is player 1. Player 2 is not allowed to do any changes to the red LEDs, so it will stay in this loop forever. Now we set the frequency value to the current frequency by using the frequency sampler object here. We use debug print here. Debug print is basically a function used to print only if debug mode is on. It will be printed to the serial monitor. Set.hexset. The hexadecimal frequency will be displayed on the green LEDs. Of course, it's debugged, so only one LED will be lit. So, if we got 16, LED number 4 will be lit. Of course, the value will be rounded down to 4. We're dividing by where the maximum frequency, if you remember, was 55. Because the fourth floor is so hard to get, it gets so unfair. So we set the maximum frequency to 55 and divided it by 10. So virtually, the maximum frequency is 5.5. We divide that, we round that down to 4, and we set it to hexset, which proved to make the gaming experience more smooth. Now, when the loop is about to finish, we check if if this is player 1. If it is player 1, we send an acknowledgement token, which is scan, to the Java code. Delay it a little bit. Then we resend the frequency again to avoid starvation. If the serial is available, this loop is not allowed to launch. The Arduino is set to be in the reading mode, which is indicated to the user if he's using debugging mode. Now it receives a code from the Java code, a command actually from the Java code, which starts either with on/off or on or off, then has a number. If it is off, it will turn off one LED, depending on the next number that is followed by the on/off token. But if the token was on, it will take a hexadecimal value and it will set it using hexset to the red LEDs, and that's about it.